Exercise 2.73, Part A. According to the quantum mechanical model for the hydrogen atom, which of the following electron transitions would produce light with the longer wavelengths, from 4p to 2s, or from 4p to 1s? According to the quantum mechanical model, as the quantum number increases, the energy increases. Actually, the energy is proportional to -1 over n squared. So when n increases, 1 over n squared decreases, but -1 over n squared increases. So really, the energy becomes less negative. Therefore, the energy increases. The spacing between the energy levels decreases. The energy level between 1 and 2 is fairly large. The energy level between 3 and 4 is much smaller. Only because 1 over 1 squared minus 1 over 2 squared is 0.75. 1 over 3 squared minus 1 over 4 squared, I think, is less than 0.1. So you can see as n increases, the energy spacing gets smaller and smaller. The transition between 4p and 1s would have a larger energy difference than this. Well, this is actually obvious, because the energy difference between 4p and 1s is the energy difference between 4p and 2s, and then you need to add the difference between 2s and 1s. So this is why. Also, you can do some calculation. You can tell, like 1 over 1 squared minus 1 over 4 squared. I think you'll get a number close to 0.93. Over here, you have to do 1 over 2 squared minus 1 over 4 squared. I think you'll get a number definitely less than 0.25. Alright? So that's why we have a larger difference here than in here. And when you have a larger energy difference, that means this transition would emit a photon with larger energy. Larger energy means higher frequency. Higher frequency means shorter wavelengths. Conversely, lower energy means lower frequency, and lower frequency means longer wavelengths, because frequency is inversely proportional to the wavelengths. There's the equation: the frequency times the wavelengths equals the speed of light, which is a constant. So when you have a longer wavelength, you have a lower frequency and then lower energy. So that's why we choose this. From 4p to 2s, this transition has a smaller energy difference. That means smaller photon energy, lower photon frequency, longer wavelengths.